Cole. I'm Vice President of Sales and Marketing here at Mazak Corporation, and on behalf of the Mazak Corporation and Yamazaki Mazak, we'd like to welcome all of you here this morning. This morning's keynote speaker is Mike Cicco. Mike is President and CEO of FANUC America Corporation. Mike's talk this morning is titled Best Practices for Integrating Automation. Mike is one of the few people, in my humble opinion, who speaks with knowledge, experience, and passion, not only about automation, but also key real-world steps that are needed to embark on a successful automation journey. Mike is in charge of FANUC America and North America, South America, and Mike also serves on FANUC Corporation's Board of Directors in Japan. Mike has been with FANUC America and FANUC Automation in varying leadership positions, a few weeks short of 25 years. So maybe we have a little anniversary. It's a great pleasure for me to introduce Mike today, someone I consider not only a thought leader in our industry, but also a great friend. So please welcome Mike Cicco.
All right. Good morning, everybody. First and foremost, Chuck, thank you very much for the warm introduction. I'd also like to thank the Yamazaki family, Mr. Taki Yamazaki, Shinji Yamazaki, for inviting me. Certainly, Dan and your team here, I really appreciate the opportunity to speak in front of everybody today, again at Discover 2023. Really great demonstrations outside. A lot of automation already that you can see outside, and I hope to just provide maybe a few more key points and updates in terms of what's been going on in the world of automation. As Chuck mentioned, I've been living this business for a long time. I started as a software engineer with FANUC early on. Chuck and I actually worked in the California region together a long time ago. So I've been programming robots almost my entire career at FANUC. I can still program robots, maybe not as effectively as I used to when I was younger, but our team brings a lot of knowledge to this business. So I hope this is a bit of an interactive presentation. I do appreciate questions, and even if right in the middle, if you want to stop me and talk about something for a few minutes, please do so, because I'm going to have some pictures and things as we go along. So I appreciate that. I'm also going to turn this mic on because I'm a wanderer when I talk, so I'm going to not move too far away here. So let me get started. So first I want to talk about. Let's see this. Okay. First, I just want to talk about the market in general, the robotics market in general, to give everybody an idea about what the robotics market looks like in general, because it's a little bit confusing. It gets broken down into a lot of different pieces, but I think it's important for you to see just how fast the robotics market is growing, and especially in a couple key sectors in terms of what the robotics market actually looks like and what it's doing. So let's get to the next one. The robotics market in general. What you're going to see here, this is a chart. These are our fiscal years, so this actually runs from April 1st until March 31st. So our fiscal year 2022, these numbers are from March in the first year up until, or April of 2022 up until March of 2023. And these are the publicized numbers from what's called the A3 organization, the Association for Advancing Automation. It's kind of our overriding organization that tracks all the robotics numbers. And you can see from 2018 up until 2022 is a very sharp upward trend in the number of robots that have been used. This is just in North America. If I were to rewind this chart back until the recession, kind of back into the 2009, you really see a very exponential looking chart that shows a huge growth in the number of robots that are used in our marketplace. When we track robots, we look at three big buckets of robot use. The automotive OEMs, these are all the robots that are used in say for General Motors and powertrain, painting cars, in body shops. Then you have the automotive component market. So these are all the robots that are used from the tier 1 and tier 2 suppliers that maybe weld car parts together. This could be robots that are tending machine tools if they're used in an automotive component facility doing engines and transmissions. So that's part of it. And then we lump general industry into one big bucket at the end, and this represents the food market, the consumer goods market, the pharmaceutical market, the job shop market, consumer packaging, a bunch of other things lumped together. Aerospace also lumped into that. So really everything non-automotive. So you have basically automotive at the bottom and non-automotive at the top. And what you see here is now we're kind of up into the 40,000 robots a year range in terms of how many robots get sold and consumed in our marketplace every year. And one of the things that you'll notice is the large growth in the non-automotive space, especially in 2021. And we've seen this trend happen for a long time. In 2020, this was the first year where we started to get where there was more non-automotive robots sold than automotive robots sold. We blew that out of the water in 2021. And then we started to see a little bit of shift in the automotive market. This portion of the automotive market really represents a lot of new investment in the electric vehicle space that has been happening over the last couple of years. The automotive market has always fluctuated up and down in the robotics business, much more than the machinery side of our business does. So the robotics market for automotive, it ramps up when there's a big program out there in automotive, it drops down when that program gets consumed. And so we see big ups and downs in the automotive space pretty regularly because we do not expect this kind of number to translate into 2023. However, if you guys remember what was happening in 2021 and into 2022, so the supply chain was in rough shape during that time. Lead times on everything were really long, including robots, including machines. And what we saw in this time frame, especially with this number here, we saw a tremendous amount of pre-ordering of equipment in 2021 that was going to be utilized much later because the lead times were so long. So this number here is a bit artificially inflated because these numbers are based on when the robots got ordered, not when they got shipped. So this is all new orders. And so this number and this number, this is a little bit artificially inflated because there was a lot of pre-ordering, and this number is a little bit artificially down because we were actually shipping robots throughout 2022. So we can kind of blend these two numbers together, and when you do that, you start to see a pretty big upward trend in robots back from 14,000 up now into the 20,000-ish range of robots. So we're talking about a lot of robots here in terms of the overall market, and I think that this chart is maybe a little bit surprising to some people to think that there's 20,000 plus robots that get sold in the non-automotive space in our marketplace every year. And obviously I'm here to talk about that there's an absolute growing trend of robots that get put on machine tools every year as well, and I'm going to drive into that as well. Is there any questions about the overall market before I kind of get into the machine tool specific stuff? Yeah.
Can you talk a little bit about the differences between the collab versus the non?
For a collaborative robot?
Yeah, exactly.
Yeah, so the question in the back is a really good one about the difference between, in these numbers, about collaborative robots and non-collaborative robots. So if you go out onto the floor today, you're going to see variations of both of those, both a collaborative robot and a non-collaborative robot. And just, I have some other slides in a minute that shows the difference, but just to quickly say, a collaborative robot is specially made to where it doesn't need a safety fence around it so that it stops if it touches a person. There's a popular trend out with collaborative robots. Within these numbers, actually the collaborative robot numbers are fairly small overall. Probably, what do you think, probably 5% or so on the collaborative side right now in terms of the overall numbers. So it's still a fairly small portion of the overall numbers are actually collaborative robots. Part of that is that in these numbers here, it's less than 1% in the automotive space. The automotive OEMs are starting to use collaborative robots a little bit on the general assembly side to like align headlights and to put in some of the soft goods inside of a car. But for the most part, there's almost no collaboratives on this side. And then as we see this is a growing trend, but still definitely less than 10% of the overall market, but growing very, very quickly. And it's a key part of what we're going to talk about today in terms of the usability of robots for sure. So that's a great question, and we'll dig into that a little bit more later. Okay. Oh yeah, sure.
specific for FANUC, or are these all robots?
That's a good question too. The question is whether these are specific to FANUC or all. This is total market, the total market overall for overall. FANUC has enjoyed a very strong market share in our marketplace, well over 50% market share of the overall market for many years. And so you can think about that in terms of our overall business as well. Okay, so we're all sitting here for a reason. It's probably not because of Chuck's good looks or my good looks that we're here listening to us today, but this is probably what we want to talk about. Is why are you sitting here? Why do you want to automate? And I bolded the top one in the right here because this has been the primary thing that I do. I go out and talk to people every day, and for the last number of years, people want to automate because they can't find workers to do the tasks that they need in the job shop. But that's not the only reason. There's a lot of other reasons. So number one is that we are here in America. People here do make a high wage. And so when you're trying to compete with somebody from a lower wage nation like Mexico or China or India or somewhere else, we do become uncompetitive when there's too much labor content in the manufacturing process. Lights out machining, this used to be, it's a pretty well-known term from before, but I like to think about this, maybe as a show of hands, how many shop owners do we have? Like how many end users are in the audience, just as a show of hands? Okay, so a fair number. How about distributors, machine tool distributors? About the same. Okay, so because I'm going to talk about both of these things. Number one, when you're trying to sell machines, and then as an end user. In terms of lights out, this is something you don't necessarily need to think about from a total lights out, like I want to make my facility total lights out. This might be something where, say you have a couple machines, you run one shift, maybe two shifts. When you start to automate, you can set up some of your systems that you might just load up that system with a couple hours worth of parts before you go home, turn off the lights and go home, and then that robot and that machine finishes off the day. So you're, instead of really thinking about your shop as a total lights out facility, once you start to automate, you can recognize that that machine and that automation runs whether you're there or not. And so many customers gain, say, a half of a shift, even if it's a couple hours of a shift, by loading up their work cell with raw parts, turning off all the lights, going home, and then that automation cell gains them a couple hours worth of production at the end of the day. So thinking about lights out production, it's not necessarily all day, all night, but it can gain you a couple hours worth of production, and every little bit counts, and so to maximize that machine productivity is important. So anything you see out there, all the robots that you see out on the floor today, you can think about that as gaining a couple hours of productivity with lights out machining, where if you're not running 3 shifts, you can load it up with parts, go home and have it produce some parts. Safety is a big thing these days. We're machining bigger and bigger things. You see the huge machine out there on the aerospace cell. Parts are getting really heavy that can get into the machines, and as opposed to using some fixed automation or a crane, trying to keep the worker safety in mind, using robots to handle heavy parts. Right now we have a robot that can pick up 5,000 pounds. A standard robot, nothing special about it, that can pick up 5,000 pounds. So if we're machining stuff into that range, we have robots that can handle it. Obviously, worker safety in terms of strenuous operations, loading and unloading parts all day long is bad. As a job shop, if you're trying to sell your business out on the marketplace to say, use me because I'm a good job shop, bringing advanced automation into there is a good selling point for you to get more business. And then certainly the overall goal is to try to reduce the cost per part that we have here. So these are just some of the other ways. As I mentioned, this number shouldn't surprise anybody. We talk about this a lot in terms of unfilled jobs. We see it, we know it. There's demographics out there that talk about it, that we have a huge shortage of labor. And everyone sees that. When you start to actually look at the numbers, 3.5 million manufacturing workers that we think are going to go unfilled. It's happening. We're right in the middle of it right now, and we're all feeling it. And certainly automation is one way to try to alleviate that shortage by trying to automate some of the more mundane tasks that exist in the factories. This is what I hear. I put this slide together because, like I said, I talk to people all the time, and hopefully this resonates with some of you, that we can't find people. Number one, when we do, there's a lack of skills needed. I'm gonna talk about education here in a minute because it's one of the most important things that I think we need to do is to educate young people about manufacturing and what real manufacturing looks like. And so I'm gonna talk about that because right now we're seeing a lot of lack of technical skills that are cut from the kids coming out of school, and then an overall lack of experience. But talent shortage is absolutely one of the main drivers that we're gonna talk about. Okay, so let's talk about the benefits here. I'm gonna go through these, and this is where I want you to stop me if you want to drill in a little bit more. So first is consistency. When you have a machine tool, you know that you work very hard as machinists to try to get the right cycle time out of your machine. I mean, you're working hard to take seconds, milliseconds out of the machining time, and you're working really hard to do that. So why on the loading and the unloading of the part do we not care so much about the consistency of that time? With automation, you can guarantee and ensure a consistent cycle time and consistent load and unload time every single time all day long. Where if you want to gauge your shop, you can look at day to day how many work pieces you produce, how many parts you produce shift to shift, day to day, with manual operations and with automated operations. And with automated operations, their robot will move per the millisecond exactly the same every single time. The millisecond that the machine is done and the door's open, the robot's going in to change the part. The millisecond that the robot's out of the way, the door's closing and the machine's starting. That lost time about manual loading and unloading of the parts does add up throughout the day. When people think about automating, when people finally make the decision to automate, a lot of times they make the decision to automate for a certain reason, where they might come in and say, I can't find people, so I'm gonna buy this robot. Once they do, they start to get a bunch of other benefits that they didn't realize that they were gonna get before. And consistency is one of them, where I hear all the time that people say, I didn't realize that I could consistently get 100 parts a shift out of my machine consistently every day. I was wondering why my part fluctuated so much, and it's because with manual loading, there's inconsistencies in that. And when you start to automate, you can get very predictable outcomes. So that's one benefit that you get with automation. Quality is another one. This is something that's becoming more and more important in terms of the different industries that are out there. But if you can imagine, once the robot has the part, so you pick up a raw part, you put it into the machine, and the robot takes out the finished part. Now the robot has it, and when the robot has it, it's fixtured in the robot's hand. And now you can add a secondary operation to that very easily, where either the robot can very easily put it into a gauge or a CMM or something to do some measurements, or the robot itself can bring it over to some device and do some measurement, whether it's with a camera or a CMM or some other measurement device. Where once you automate, you kind of get some inherent quality checks built into it, because now the robot has it, and while the next machining process is going on, you can use the robot to actually gauge and automate that process as well. So now you can offer to your end customers, or you can sell 100% quality checks on the parts that you make, because you can use the automation to do two things. It can load and unload the machine, and then it can gauge or load and unload a CMM or something like that as well. With no additional, it kind of comes with it for free, as you might think about. So that's a really, really good part as well on the robots. And then the other thing is the robots are so precise, you really eliminate any sort of misloading. A robot's accurate down to tenths of millimeters, and so you're, from a loading perspective, can be much more accurate than manual loading. Efficiency, I see this on some of the machines out there. Actually, there's a machine down at the end that has the robot and the gauge all automated together that you can look at. But this is another key part, is just hooking up multiple machines. This is a little bit out of the job shop realm, but more on the production machining side, where you can put multiple machines together with one singular robot. You can organize the machines. I saw some of the machines out here with side load doors or top load doors or front load doors. So you can configure the machines where, like in this particular case, the robot's going in through side doors, whether on either side or on the back. So it keeps the front of the machine open for some manual operations if needed, and then the robot's tending multiple machines from the side or the back. So this is a really highly efficient way, again, more on the production machining side, but to take different operations all together with one robot and various machining capabilities. Safety, I talked about this before. We've got a robot, it's the one down here on the bottom that can pick up 5,000 pounds. So this is an area where the dedicated equipment needed to handle big heavy parts like cranes and riggers and stuff like that can get pretty expensive. So we have robots that can handle really heavy parts. So keep that in mind as you're thinking about it. And then finally, this is to the gentleman's question up here about collaborative robots. This is a really new and growing part of the market, which you see on display out here. There's a number of systems from RoboJob that's out here, one of our system integrators that puts a pre-engineered solution together. These are from Ultratech, one of Mazak's distributors that's here in attendance as well, where a pre-designed system that you can easily move around from machine to machine. You can easily hook up to a machine and you can easily deploy on different parts is becoming one of the fastest growing trends in the market. This is what's driving a lot of the collaborative robot growth today, because these robots are very lightweight, so they can move around very easily. They can program very easily because of the way the robot's configured, and it's a really, really nice thing for a job shop to be able to invest in and start to get going with robotics very, very easily. They're also very low cost because, as I mentioned before, with a collaborative robot, you don't need any safety fencing around it. So with this, you eliminate the need for that kind of safety fencing, which then brings the overall cost down as well. So you can see in some of these designs, really, I mean, this is a robot that's on a small pedestal that's fixtured to, it's on wheels, but then casters come up and so the robot sits in place. This part device is on wheels that then can be just locked into place, and you very simply just program the robot, where you can easily program this thing to machine however many parts that is, 20 parts or so, and let it do its thing and then reprogram it after it to do the next part. So you can do a small batch of a couple parts. You can let the robot run. It only takes a few minutes to drag it over and teach a couple new points to do the next one, and you're off and running again. It's a very, very simple way to program the robots, and this is a very, very quick growing trend that's out there. Getting a little bit more into collaborative, I'm going to talk about how collaborative works here. So you can see a little bit more close up on the collaborative robot here. The way these collaborative robots work is there's a sensor in each one of the robot joints. So a robot it has 6 axes. It has a waist like a person down at the bottom, the first joint. The second joint's more like your hip. The third joint up at the top's like your shoulder, and then there's 3 joints at the end that work like your wrist. But in a collaborative robot, each one of these joints has a torque sensor built into it, so that it's always monitoring the force that the robot's sensing. There's a lot of complicated software that's built into it, so it knows what force it should be seeing and then what force it shouldn't be seeing. But once it sees a force that it shouldn't see, it stops. That's how a collaborative robot works. But the other benefit of a collaborative robot is you can put it into teaching mode, and then those servo drives actually soften up, where you can grab the robot physically and start to move it around by your hand. So instead of using a teaching device, which is what a traditional robot uses, you can actually take hold of the robot and grab it and teach points with that. And a lot of the integrators actually integrate a small button onto the tool of the robot, where then you can actually use that button to teach points, and very simply program the robot to perform whatever task that you want. And like I said before, I'm talking in minutes. We're not talking about something that takes a long time. This is within minutes you can go and teach robots to do this. So very easy to use. The programming software has been rewritten to be very easy, very low cost because of the lack of other equipment that's around there. No fencing, easy to program, easy to redeploy. So you're absolutely not dedicating a piece of automation to a machine. You have a piece of automation that can be used amongst multiple things. Even if you want to use that automation later, a lot of companies will put a camera on the end of this. So say I'm talking to the end users now. Say in your shop, you have a machine shop where you're making things, but then you're adding other value. So maybe you're assembling the components that you're machining. So your output isn't just a machine part, but it's some device or something that you're actually making all together. You can redeploy this by putting a camera on the end of it and actually taking pictures of the things that you made and making sure that your operators put the screws in right, that they put the sticker in the right spot, that they assembled it into the package the right way. So you can then redeploy this asset to do a lot of different things besides just tending the machine. So it's a really nice way to do that. And as I mentioned before, it's a really easy entry into the robot, very low cost to dip your toes in it and try. This is our specific, this is a little bit, I don't mean to be a FANUC commercial here, but we do make a robot, this called the CRX that you'll see out there as well. Okay, so this is the part of the presentation where I present for a while and I see like people nodding their heads like, oh yeah, it sounds pretty good. And then in the back of your head, you're like, yeah, but I'm still not gonna do it. It sounds good, Mike said a good thing, but I'm still not gonna do it. Because I've been giving this presentation at this for a long time. And this is where I just want to tell you, like, the biggest hang up is just not doing it in the first place. Just do it. And I think that's my next, just do it. Like, you can do it. It's like less than 100 grand. Just make the investment and do it. And I promise you, once you do it, you're gonna do it more. You're gonna find a benefit that you didn't recognize. You're gonna see how easy it is, and you're gonna do it. So if you were listening to me before thinking, that all makes sense, yeah, I have those problems, yeah, those things exist in my shop, and then you're gonna leave here and be like, yeah, but I'm not really gonna do it. I'm telling you, just try it. Just try it, and even with us directly or through some of the integrators, we have lots of programs out there where if you try it, you don't like it, we'll sell it to somebody else, no problem. But just try it because you're gonna find something that you appreciate or that you can utilize about it that you didn't think about before. And that I hear all day long is, man, I can't believe I waited this long to do that. So I'm telling you, you can do it. So here's why. Number one, they're not that complicated. And one of the biggest hang-ups used to be is, I've got a bunch of different controls out there and hooking up the robot to the control system's hard. And we've solved that problem. Number one, there's a really sweet interface called MT Connect. It's a standard interface that Mazak's a huge supporter of. FANUC robots support MT Connect. It's a built-in interface where all the I/O points are defined, the machine's defined, the robot's defined. It's super easy. The second is pretty much every robot, not just FANUC robots, but every robot and every machine control type has come up with a robot interface by now. This was a problem like in the 90s. This is definitely not a problem 20 years later. Hooking up a robot to a machine tool is not a problem. Number one, as I mentioned, collaborative robots and movable fences make it really, really easy. This is a picture of the RoboJob, one of the RoboJob cells that you see outside. One of the things that you can see here, because this system actually doesn't use a collaborative robot. So when you go out there and see the RoboJob systems, it uses a non-collaborative robot, but there's safety sensors that are built into the base of the system, like here and here, and they sense where people are without needing a fence. So it works without a fence. It's still movable, it's still portable like we talked about with collaborative robots. But these safety sensors at the bottom, if you get close to it, it senses your legs and it stops, or first it slows down and then it stops, and still manages the safety. So there's lots of ways to make fenceless systems, even with non-collaborative robots as well. And then as I mentioned, certainly on the collaborative side, you don't need a fence regardless. This is just protecting the conveyors from people. In-feed types. You see a number of different examples of this out on the floor today. Certainly small trays where you can this is a lot on lathe operations where something starts as a circle or starts as a cylinder and ends as a cylinder, where it's really easy to do that. You can see various other in-feed types. Hooking up a camera to a robot to see things is also really easy to do right now, so there's a lot of different ways that you can feed parts into the system. So this is using a camera. This is another thing that used to be a big hang-up for builders and users to come in and try to integrate. So trying to hook up a camera, so in this system there's a couple cameras that are kind of here. This system, there's some cameras above it. Certainly this system has some cameras. To try to find parts that are just located on a pallet used to be a pretty challenging thing to integrate when it comes to robotics. And through a lot of advancement over the years, it really isn't as hard as it was before. We have pre-canned software that integrates right into the robot. All the cameras come directly from us and other robot builders, to be honest. There's a lot of other things that are integrated into the robot. And it's really just a pretty simple added feature to the robot, where you can not only find things in 2 dimensions, but you can find things in 3 dimensions. So in this particular case, these parts, they're on these pallets, but you can tell it's just a wood pallet, so it's not perfectly located. It's off in 3 dimensions. So these sensors here, these sensors that are up here, are actually finding these parts in 3 dimensions and guiding the robot to pick them in 3 dimensions. And this doesn't take a PhD student to figure out how to program this. This is something any robot programmer can integrate and do. So it's really not that hard. And I'm kind of getting to the end here, but this is then the final point. So at the beginning, I talked about that maybe you want robots because you can't find people to tend your machines. But then I said, well, maybe you're still questioning whether you want to get robots anyway because you're still nervous about whether you can make them successful in your facilities. And one of those big problems is that you don't have anyone in your facility right now that knows how to operate, maintain, or use a robot, that's a new piece of equipment. You have a lot of people that might know how to maintain or program a CNC machine, or some of the chip conveyors and some of the measurement equipment. But if robots are new to you, then you need to somehow either train people or find people that know how to program robots. And this is how I'm going to tell you how to do that. So partnering with education is something that we need to do more of. This is a little bit, I'm going to step up like on my imaginary soapbox here and talk about. This is a big pet peeve of mine, that as business owners and as I look around the room and we have some of the pillars of our industry in this room from the machine tool perspective. I mean, we have absolute leaders, people that are running entire distributors and builders in this room. And we need to do a better job partnering with education to tell them what we do for a living and why it's important and what they need to teach the kids in school so that when they finish school, they're relevant to us. Because obviously we need lots of people for lots of things, but we also need people for manufacturing, and we don't do a good enough job telling the schools what we need for manufacturing. And so this is I'm going to show you a little bit of what we've been doing, so it's going to help you find people to program robots. But it's also a plea to you to do this, to partner, to find your local community college, talk to your local high schools, find the local colleges and say, I want to partner with you, that I run this machine shop or I'm this machine tool distributor or whatever, and say, what do you talk to your kids about in terms of manufacturing, and can we partner together? And that way you get new employees from them, they get to learn about what really happens in the real world, and everybody's happy. I can tell you firsthand that schools are dying for this. Schools are begging for industry to come talk to them about what the real world is like. So what have we done? I recognize this. I've been CEO since 2016. This is an effort we started before I became CEO, but I was heavily involved in it, where we started selling robots and CNC controls into the education system. And now we're located in about 1,500 different schools across North America. So for wherever you're located, I know we have a lot of people from the South and Canada in here, and I apologize, my map doesn't show Canada. I always do that, and the Canadians always get pissed at me for not doing it, but I apologize. I was nominated as an honorary Canadian a long time ago, but we do have schools in Canada as well. But within this chart, what you see, where I put my pointer, but everywhere there's a dot, there's a school that either has a FANUC robot, and then probably in conjunction with that, a FANUC CNC, and they're teaching kids how to use it. Primarily, it's at the community college level, and then about 50% of those dots are community colleges, and the remaining 25 are either high schools or college level classes. So my thought to you is that if you want to invest in automation and you are thinking about, well, maybe I don't have anybody in my facility that knows how to do this yet, go talk to one of the community colleges, go find the latest VOTEC class in your local high school, and grab some kids coming out of school and get them into your facility. It doesn't cost you that much, and I'm telling you, what we have in this program, what you see in this picture of these kids programming this robot, what we've created is we've created a small cart with a robot on it, and we've wrapped an entire curriculum around the robot itself. So part of it we donate to the school, part of it we sell through grants and other things, but what they get is they get a physical robot and that comes with a semester-long class that then we take the educator and we bring them to FANUC and teach them how to teach the class. And so what we have now is consistency. So all these schools are all teaching the same classes, and they're stackable. So there's basic and mid and advanced and super advanced. We add safety and IoT and stuff onto those classes, but they're all learning the same thing. So, and we made sure that it's relevant. So we're not doing Legos and toys and stuff like that. We're teaching skills that they can use when they get to your place. So finding a conjunction, going to one of these dots and making a connection and shaking a hand and trying to do that is gonna get you people that are relevant to your organizations. Not just for robotics, but other things as well. So this is a big effort for us. We feel very strongly about it. And it's a way that if you're thinking about getting into automation, but you're worried about not having people, this is a way to get people. On the flip side of that, community colleges are always looking to retrain your existing employees as well. So keep that in mind as well by offering a different career pathway to some of your existing employees and operators to have them go back to a class. It's only a semester or two to go back and learn that skill as well. It's really, really important, and it's something that we're trying to take a leadership position in, and I think we're doing a good job so far. Anytime FANUC hires new people, I give an opening presentation like this to our new employees, and for like 3 straight years, I've asked the crowd, who has touched a robot in high school or college? And at least one person's raised their hand in every single class that we've done. So the people that we're touching are making their way into industry, which is important, and so I think what we're doing is working. So this is my last slide. So now hopefully I've given you all the things that you need. What do I do next? So the first thing to do, especially if you're in here as an end user, got to talk to Mazak, talk about what your needs are, because everyone's a little bit different in terms of what is that trigger that's going to get them started. Certainly work with your distributors. A lot of the distributors have local partners that they use to find an integrator. So if you've never done it before yourself, a lot of times you want to find a partner to go through that can help you along the way for your first one before you either want to try to do it yourself or continue to build that relationship with a partner. But you gotta just do it, just pick an application and go. And then finally, I want you to know that we're obviously here to help. I've got a couple of our group here from our local office here in Cincinnati, both sales and engineering here from FANUC that can answer a bunch of questions. But no matter where you are, we have 24 different offices in North and South America, 2,000 people, all here to help teach about robots and automation. So we're definitely here to help you. Okay? So with that, I think that's it. Now let's get some additional questions. Mr. Miller. Yeah, sure. So Chris's question was about end of arm tooling. So obviously, when we make a robot, the end of the thing that we make doesn't have a hand on the end of it. End of arm tooling is the thing that comes at the end. In the machining world, because we're typically dealing with things that are made of metal and hard, typically you're using some type of gripper, whether it's a parallel gripper that comes in from 2 directions, or a 3-jaw chuck like you'd normally have on a lathe or something like that. That's where the system partner or the technology that you might start to build internally comes into play. So depending on what kind of parts you need to handle, the type of gripper that you need changes. One of the things that I talk about is that a lot of people get afraid of that because, oh, now my parts are going to change. So how do I make different end of arm tools work? The good thing is you're all machinists. You know how to machine things out of metal, and those grippers, they just have a different stroke to them. And all you need to do is machine a new set of fingers to pick up different size parts. So don't be so scared to say, my gripper picks up this part, but it can't pick up the next part. Just machine some new fingers to make it pick up a different part, and then it works for various things. Automating a lathe is probably the easiest thing because everything starts round and ends round. As you get into some of the multi-axis and some of the integrated stuff that Mazak has, where something starts one shape, it comes into a completely different shape, you start to need to put a little bit more thought into how you grip those parts and where you grip them and things like that. And that's where some of the small parallel grippers come into play, where you can grab a part in a lot of different areas as well. So it's a good question, but that's where some of the system integrators can help you. The other thing to note is that there are things what are called an automatic tool changer on a robot, where you can go drop off one gripper and pick up another gripper, like changing your hand. So I can go pick up a parallel jaw gripper to go pick up one part, and then when the part's finished, I'm gonna switch my hand to a different hand and go pick up a finished part that looks a little bit differently. So there's those as well, tool changers. Same thing like a tool changer on a machine. Okay, what other questions do we have? Yeah?
What's the role of AI as it relates to automation in your mind?
That's another really good question. What's the role of AI in terms of automation? For me, I've been saying the same thing. AI is, in our world, equivalent to ease of use. That using AI, artificial intelligence, what artificial intelligence does for us is it takes something that's very hard and complicated and makes it very easy to use. For example, the 3D vision stuff that I was talking about before, taking a camera that uses 2 cameras, a structured light, a very complicated internal housing of this thing, and turns it into something where all you have to do is project an image, click on a picture, say where you want to pick it, and then it picks it. There's a ton of AI that's working behind the scenes to get all of that stuff done, but the final result is that from an end user's perspective, you get a very easy outcome of it, where you see an image, you tell the robot where to go to pick it up, and it works. It's kind of like if you think about ChatGPT, you tell it to write a speech for my going away party or something. There's a lot of AI working behind the scenes that's telling you, but it's easy to you because you told it to do something and it gave you a simple output. So to me, AI it should be transparent to you as the users. The AI is on the back end, and we're just trying to use it to make it easier for the users to do. And the vision part of our business is a big part of that. We also have a sensor that's called force sensing. So if you're starting to assemble machine parts that have a tight fit, you can put sensors on the robots to actually press fit things together. And there's a lot of AI that's built into that as well, that all you tell the robot is take these 2 parts and put them together. But then there's a ton of AI working in the background that's going through some, it's nerd stuff, but regressive algorithms that are putting things together. So that's what I think about AI is that we use it a lot, but we do it to make some of the hard stuff transparent to the end user and make it seem really easy.
So, sorry, follow up. So do you see that as a new method of programming a robot to do certain things?
That's right, yeah. So to use AI as a new method of programming where it used to be in order to train a robot to pick random parts out of a bin, it used to require a tremendous amount of custom programming by the user to be able to get that done. Using some of the AI software we've developed, it doesn't require that anymore. You train an image, you say pick here, and a bunch of AI stuff happens in the background, and somehow magically the robot goes in there and picks out the part that you want. That's how we're using it. Yeah, good question. Yeah.
As a small job shop with ever-changing components, what would be the minimum amount of minimum quantity to automate a machine?
Okay, good question. So as a job shop, ever-changing lot size, part quantities, what's the minimum? I'm gonna go back to like this. This is a perfect example where literally in this system, what is this? 5 times 30 parts. So there's 30 parts in that tray. This system, the way this system is designed, that system cannot do more than 30 parts. It's designed to do 30 parts at a time, and then you load it up for 30 more parts. It probably wouldn't be effective to do it for 1 part because it doesn't make sense. But I've seen people do it for 4 or 5 parts because once you set this thing up, say you had a tray like this where it was simple, where I'm trying to show the best way to explain this. Say this is your machine and you ran various parts on this machine, but because of the machine type, the incoming diameter size of the part was always about the same, but the outcoming stuff varied because you didn't know what part you were doing next. You could set this thing up and a lot size of 5 came in. You just wanted to set it up and forget it. You didn't want to worry about it. So the teaching of the incoming points, so like 1, 2, 3, 4, 5. So all the robot would know is that there's 5 raw parts here, so just this first row. And all you would need to reteach is the pickup point. So because of whatever custom thing you did to that part, when it was finished, the robot maybe needs to go to a little bit different position to pick it up. So you just need to teach 1 point for your custom job, and then what that might take an hour, it might take 20 minutes, but it's not someone standing in front of the machine for 20 minutes while everything's doing, you just set it up and forget it. So to answer your question plainly, 1's probably too few, but a couple, it depends on the machining time. It's just a matter of once you learn how to do it, and once you get that program, you recognize it's gonna take you a few minutes to touch up a point, but then you can free up somebody to go do something else within your shop for the next hour or so. 30 minutes, even that is beneficial for you. So a lot of it is getting your people comfortable with manipulating this and changing a couple points. Machine tending is really easy. You just pick up from here, you put in there, you take out of there, and you put over there. It's really not that complicated. That's only 4 points, 1, 2, 3, 4, that you have to modify. So when you want to make a change, you modify 4 points. It takes really simple. And the program's pre-programmed where with something like this, it's all calculated with math, where you just teach to pick up this point, and the robot knows that this grid is so many millimeters this way, and so all these points are calculated. Same thing with the drop-off point. You just teach this one, and then it goes through it calculates that automatically. So it's really not that hard. So that would be the way I'd answer that. Yeah.
You talked a lot about machine tending for the robot.
I didn't think it were
Yeah. So that's another really good question is, as I said, there's 40-some thousand robots each year. How many are actually machine tending? I'm gonna say unfortunately, because for whatever reason, we don't have machine tool tending as a category where we can know it. We know material handling, but that could be me moving a box from here to here, not necessarily tending a machine. So I'm gonna give you various levels of estimation that, number one, we think that only about 10% of the machine tools that are sold are automated in some way, not even with robots, but Altech systems and other things are actually automated. And so I would estimate that it's probably 15-20% of that number of the non-automotive side is some level of machine tending. So we're kind of tracking that as a side number of what we know of different distributors and machine builders that are doing it, but it's still a pretty small number. We have a huge growth opportunity, which is why I keep preaching and talking about this, is because of how much growth, how much opportunity we still have for that. So it is a smaller number for sure. We're out of time. You get Stokey okay? One more? I don't know. It depends on what he's. No? Come on, Steve. What do you got? Give me an easy one.
So you talked about machine tending. So can you take just a couple minutes and talk about what's possible with the explosion of Amazon and distribution centers? How should we be thinking about robotics that shipping and packaging? What's possible?
Yeah, I'd encourage this. It is a good question, Steve. Not surprisingly, but I'd encourage people to Google what Amazon. I'm not allowed to publicly talk about relationships from confidentiality, but just Google what Amazon's been doing with robotics, and you're going to see something. This is where some of the AI questions came in, where you think about a robot that's presented with a huge bin of completely random stuff, boxes, bags, poly bags, and all sorts of other stuff. And the robot needs to singulate those things out one at a time very, very fast. So there is a huge transformation in robotics now in logistics because that labor, not only is it just as strenuous as tending a machine, but it happens much, much faster. I mean, you're handling bags and boxes every second. And so there's an evolution now in robotics that's happening very quickly, and this is driving a lot of our AI technology because handling stuff for the logistics space is a whole new frontier. I'm going to predict it's going to be bigger than automotive in a number of years. That there's an opportunity there. How many people work in logistics right now in warehouses? It could be bigger than automotive in terms of the volume. So definitely. Okay. All right. Thank you very much.